Hello everyone, I am presenting our paper Semi-Supervised Domain Adaptation with Auto-encoder via Simultaneous Learning. Let's go for the motivation. First, our motivation is the auto-encoder, how we can use auto-encoder for semi-supervised domain adaptation, where the label of the source domain are available, but most of the labels in the target domains are not available. And how we can achieve strong domain matching in the domain adaptation scenario in the bottleneck layer of the autoencoders of source and target domain. And another motivation is how we can use simultaneous training of source and target autoencoder to achieve strong domain alignment in the bottleneck layer efficiently. Here is a brief explanation of how our simultaneous domain adaptation framework works. Before domain adaptation with the source and target domain, there is a confusion in the classification, and in simultaneous learning the source and target domain got aligned simultaneously, and the divided line of the class confusion layer, it's also get aligned to separate the source and target domain. And finally in the adapted model, it can successfully classify source and target domain in all the classes. And let's get how domain adaptation with autoencoder framework works. First, we use simultaneous training of autoencoders with source and target autoencoder, and second, we take the trained source encoder and we attach the classifier layer, and we train the classifier with free source encoder, and then we transfer the classifier to the target domain, and then we do semi-supervised fine-tuning in the target domain, so we can achieve domain adaptation in target domain. And now we get to the how simultaneous learning works. In simultaneous learning, we adapted class-wise MMD loss. This is a modified version of the MMD loss, where we aligned two different domain in the bottleneck layer of source and target autoencoder with MMD function, but this MMD loss works in corresponding classes of source and target domain. And there is a reconstruction loss. This reconstruction loss tries to reconstruct the source input image, and then we combine the reconstruction loss and class-wise MMD loss with a training parameter beta. So beta parameter signifies the importance of class-wise MMD loss and the reconstruction loss. Finally, we also included a dummy layer which connect the source and target autoencoder in a single graph. And here's the bottleneck visualization. In this visualization, we can see that in the target domain we achieve domain adaptation successfully, where the individual classes are in a single cluster. And finally, in conclusion, we say that our modified MMD loss with simultaneous learning successfully achieves cross-domain distribution matching, and the experimental evaluation shows superior performance in semi-supervised domain adaptation scenario.